Okay, so now we are going to solve this tree problem called as subordinates from the CSES problem set. Okay, so let's go through the question first. So given the structure of a company, your task is to calculate for each employee the number of their subordinates. Okay, and also let's see the input. The first input line has an integer n, the number of employees, and the employees are numbered from 1 to n, and employee 1 is the general director of the company. Okay, fine. And after this, there are n minus 1 integers for each employee from 2 till n, their direct boss in the company. Okay, so the thing is that n denotes the number of employees in the company, and then we have n minus 1 integers after that, which represents uh, the bosses of all the employees from 2 to n. So it means that since 1 is the general director of the company, he will not be having a boss. So it starts from 2. So 2 has a boss of 1, 3 has the same boss 1, and 4 has boss 2, and 5 has a boss 3, right? So this is a hierarchical structure that is being formed. So let's look at this structure here. Okay, so just 1 minute. Okay, the input is something like this: 5, and then we have 1, 1, 2, and 3. Okay, so 1, 1, 2, and 3. So you know that we have 5 nodes or 5 employees numbered from 1 to 5. So something like this. Let's say 2, this is 3, then 4, and 5. So each of these are nodes or employees. Now let's go through this input. So this represents that 2 has a boss 1, 3 has a boss of 1, 4 has a boss of 2, and 5 has a boss of 3, right? So let's write it down here: 2, 3, 4, and 5. So 2 has a boss of 1, we can connect 2 and 1. Okay, and then 3 has also a boss of 1, so you can connect 1 and 3 like this. So this is essentially a parent-child relationship in trees. So we have an directed relation from 1 to 2. Okay, then 4 has a parent of 2, something like this, and similarly 5 has a parent of 3. So this is the tree representation for this example. Okay, and now let's see the output. So the output is 41100. Let's see how it comes like this. Okay, so we have to calculate the number of subordinates, right? So let's say start from 1. Okay, we keep a vector here. So let's say like this. So 1, 2, 3, 4, and 5. So this array here will store the number of subordinates for each employee, for 1, for 2, for 3, for 4, and for 5. So if you see it here, so the number of nodes or number of children that 4 has is 0, right? So basically it has no employee working under him or her. So that is 0 subordinates. So we put 0 here. Similarly for 5, there are no children after it. So 0 or 5 as well. And for 3, it has one children, which is 5. So only one subordinate or employee. So for 3, we put 1. Similarly for 2, we see that we have only 4. So we put 1 here also. And for 1, so for 1, what is the case? The case is that we have seen that 2 and 3 are there. But 2 has a subordinate of 4 and 3 has a subordinate of 5. So in total, from this left half of the of this tree, we're getting 2 subordinates. For the right half, we're getting 2 subordinates. So if we add them, so we have 4, right? So this is the same thing. We're getting 41100 as the answer, right? So, so it is this like this only. Okay. So now let's look at one more thing. Like in a binary tree, what happens is we only have. Okay. Just a second. Okay, so let's look at the data structure that we'll be using. So for a normal tree, for a binary tree, what we have at most two children, right? So the node structure, the class structure that we use looks something like this. We're gonna have a class node, and inside of it we generally have something like this int value, and then two pointers to the node class, which is nodes are left and the nodes are right? Okay. So for a binary tree, this is the class structure that we generally use. We have a value to that node, and also we have left and right pointers. But in our case, what we have seen is that this is a inherit tree, right? So any element, let's say one or two, they can have multiple trees or n number of children. So let's say we have two and we have one, right? So something like this, and then two can have, let's say, three, and then four, then five, and then up to like this, say in children, right? So it has in subordinates working under it. So this can happen, right? So definitely we can't use this data structure here, this class node, something like this, right? We have to modify it. So what you can do is basically you can keep a collection of nodes, right? So for that we can use a vector data structure, right? Okay, so we have vector node star v. So this vector will uh, contain the references of all of its children, right? Now, okay, so now let's see the implementation, how we'll solve this problem. Okay. Okay. So yeah, so this is the node class that we talked about. So we'll be having the value, and we also will have a vector of nodes, a collection of nodes to represent all the subordinates of a particular node, right? We have named it child, and this is the constructor. So if we initialize a node, we'll be initializing it to the value d, which represents the node's value or employee number to be precise, and then we set value equals d, right? Fine. Now let's go move on to the main function. So first we'll be taking the input n. So this will contain the number of nodes or number of employees, and then we'll create a map, an ordered map to hold all the nodes for each employee. So we have n nodes or n employees, and for each employee we'll create a node, right? And to hold the reference of that node we'll be using a map. Okay, so in this loop we are iterating from 1 to n, and for each I we are creating a new node and assigning it with I only. So the value it will contain is this I, or 1 2 3, something like that. Okay, so basically it means that, so 1 will have a value of 1, and then 2 will have a value of 2, something like this, value equals 2, and the v will contain the elements, let's say 3 4 5, the references of all the elements. If 2 has all the subordinates, the vector will contain the references of all that subordinates. Okay, now okay, so now what we'll be doing is we'll making the connections in this loop. So as we know that our input will contain n minus 1 elements, and from the first element, like this represents the boss of 2, this represents the boss of 3, and so on, right? So in this particular loop we have kept I from 2 till n, and we'll be taking the input and then we'll be mapping that particular, making the connection from boss to the children or to the employee. So mp of x, this means that we'll be pointing to the node star, and then since it's a pointer we'll be using the arrows notation, and we'll be accessing the child element, so basically the vector here, and we'll be do a pushback of mp of I, right? So it means we'll be pushing back that address of this node. So for example, if x is 1, what happens is mp of 1 gives us the address of 1, and in the address of 1 in the child element of 1 we are pushing back, let's say, mp of 2, and now mp of 2 will contain the address of 2, right? So essentially we are pushing the address of 2 in the child vector of 1. So we'll be doing this for all the elements, for all the input, right? So now we have a working graph with all the connections made. So now let's move on to the next part where actually we'll be counting the subordinates. Okay, so what will be the strategy here? So let's say we have 1. Let's draw the example that is given in the question. So 2. Okay, so we have 3, and here it was 4. 2 was connected to 4 and 3 was connected to 5. So this is the example we have seen in the question, and now how we'll proceed with this. So if you can see that for a particular leaf node, so let's say 4, and it has no subordinates under it, working under it. So basically the child element of 4 will have a size of 0, right? So because we have seen, right, that this child element will store all the references of all its subordinates, but since 4 has no subordinate, this size of this child vector will be 0. Okay, so we'll write the code as such that if the child vector size is 0 for a particular node, then it will return only then it will return 0 because it doesn't have any subordinate. So let's say 4, what will return to 2, right? It will return 0 because it doesn't have any doesn't have any employees, right, subordinates, plus 1. Why 1? Now 1 is because it has to account for its own contribution as well. So 4 is a particular node, right, which is under 2, but 4 doesn't have any subordinates, so for that it will return 0, but plus 1 while returning because it has to account for 4 itself as well, right? So it will pass total 1 to 2. Similarly 5 doesn't have any children, right? There is nothing here, so it will return 0 plus 1. Plus 1 accounts for the 5 itself, so 3 will get 1, 2 will get 1. Now what about 1? What will it get, right? So you can see that 2 has only 1 children, right? So it will return what it got from the its subordinates plus 1 to account for itself, right? So it will return 2. Similarly 3 will have return 1 what it got from 5 and from its subordinates plus its own contribution, which is 1. So this will return 2, right? So 1. So in the answer array, so we'll be basically for 1 we'll be storing 4. 2 plus 2 4. For 2 we'll be storing 1. Okay, let's do the indices first. 4 and 5. For 2 and 3 if they get 1 from their subordinates, so 1 each. And 4 and 5 they don't have any children, right? So we'll be having 0. This is what is the answer array is going to look like. Now if instead 2 had, let's look at some scenario like if 2 had more multiple children, what would have been the case? Okay, so if 2 had some element, let's say 6, one subordinate, one more subordinate, let's say 6, right? So 6 doesn't have any subordinates, so it will return 0 plus 1, so 1, right? Similarly, so now 2 has, it's getting 2 subordinates, one subordinate here 4 and another subordinate is 6, and so it will return 1 plus 1 plus 1 to account for itself, right? So it will return 3. So for if a node has more than 1 children, then we'll have to take the number of subordinates of all the children. Okay, So this is we'll see in the code how it's done. Okay. So now going to the code. So how I'll do that, we'll run a depth first search. We'll do it in a depth first search manner. Okay. So as you have seen that we'll start from 1, we'll make a call to 2, we'll make a then 2 instead will make a call to 4, and 4 will make a will not make a call because it doesn't have any children, so it will hit the base case and it will return 1, right? Now 2 has, if 2 has more children, it will go for those as well, and finally it will return all sum of all the subordinates plus 1 to 1. Similarly, if 1 will go, now will go to 3, 3 will go to 5, 5 will return 1, 3 will return 1. Now if 1 had more multiple elements, let's say 8 will go to 8 as well, 8 will return its contribution to 1. So this is like iterating over all the nodes. We start from the top and we iterate over all the children, return the subordinates and then sum it and then store it in the answer vector. Okay, so this is the vector that we have created for the answer. So we have, since this is a one indexed numbering in the question, so it starts from 1, right? So we have vectors as n plus 1, so it will have index from 1 to n. Initially all are having 0 subordinates, we have assumed, right? So it's initialized with 0. Now we're calling this function dfs, which starts from the top as discussed, and then we're also passing the map that is required and also the answer vector by reference. Okay, now let's have a look at the dfs function. So it receives the node, it receives the map, also the answer vector. Now first is the base case comes. So the base case will hit when a particular node doesn't have any subordinate, right? So in that case, this size of the child vector will be 0, right? Because it doesn't have any subordinates. So in that case, the MP of node, which is a pointer to that node, and then child dot size is 0, right? Then it returns 1. So 1 means basically its own contribution, right? Now if it doesn't, if a node does have children, so what we'll be doing is we'll be iterating through all the children. So MP of node of child is a vector, and we'll be iterating for auto ch in this vector. So we'll be iterating with over all the children, and in the answer we'll be adding up all of the contribution from all the children. Okay, so a DFS of ch comma val, right? So basically we're pointing to that a value of that particular node, right? So we're calling the DFS function over all the children, and we're summing up all the answers and storing it in the answer of node in its own index in the answer array. And finally, when a node has taken the contribution of all its children, it will return answer of node, which is the contribution of all the subordinates plus 1 to account for its own contribution to its calling node. Okay, so in this way, we'll after this has been done, we'll have the answer array filled as required, and then we'll be outputting the answer from 1 to n, because we have the nodes numbered from 1, not from 0. So we'll be doing cout of answer of I. Okay, so this is how it's gonna be, and you can see that this code is accepted, it passes all the test cases. So it's the same thing. Okay, so thanks for watching everyone, have a good day.